and we look forward to the questions. Go ahead. Thank you.
Good day, everyone.
This is being recorded.
Thank you for tuning into my presentation. My name is Mickhal, and today I'll be presenting the feasibility of powering a Manzanilla via a wind farm. Initially, my objectives were to figure out the average power consumption of the area of Manzanilla, which is under focus, which is actually a smaller subsection of Manzanilla that itself, to determine if the wind source in the area is enough to meet the demand of power in Manzanilla, and to determine whether it will be viable to install that wind farm in Manzanilla itself or not. As mentioned earlier, the area I'm focusing on is a small subsection of Manzanilla, which is just the area you see here, the North Manzanilla Road, the Eastern Main Road, Manzanilla, between the gas station and the coastline. In that area, there's about 300, so exactly 297 structures, so, the majority of which are residences, some of which are just businesses, and the combinations are a fusion of buildings that have the purpose of both residence and business. And initially, when I estimated the power consumption of 8,910 kilowatt hours, between the range of 8,910 and 9,900 kilowatt hours, which was based upon the total occupancy and electric consumption of the area from a survey I conducted. Later on, I got information from a TNTech employee, which placed the value at 1 megavolt amp, and that was measured between 6 a.m. and 6 p.m. I was also given a power factor from that same employee as 0.8. In calculating, I got to the real power consumption of 800 kilowatts for a 12-hour period during the day. From the research, at minimum, what is necessary to start to spin a turbine, the wind speed should be at 4.97 miles per hour. And to actually begin decent power generation, you would need 7.82 mile per hour wind speeds. Unfortunately, I was not able to measure the wind directly, but I was able to gather some information from two sources, windfinder.com and weatherspark.com. Windfinder actually shows snapshots of the wind speed at a given time and is updated every 8 to 12 hours. And WeatherSpark has historical data measured over a year. This first image, which was taken March 23rd, shows a wind speed of 12 miles per hour just on the coastline, right near Miyaro Beach. And the following image shows another snapshot later in the year, around April 22nd, showing a wind speed at 10 miles per hour. Just from those two snapshots alone, you could begin to assume that the area has a bit more than bare minimum wind speeds to generate electricity. But going forward, I have a table which took measurement throughout the week, which gave an average at around 12 miles per hour. And going forward even more, according to this chart, it shows the wind speeds fluctuating throughout the year, but never actually hitting below the earlier benchmark mentioned, which was around 7 miles per hour. Now, here in the UK, where they actually have larger wind farms which service a greater subsection of their country, it shows that usually their wind speeds fluctuate between 11 knots and 7 knots, the peak of which is around 12 miles per hour and the lowest point is around 8 miles per hour, right? Those wind speeds actually coincide with the wind speeds that we have and that I have shown from my earlier research. Now onto the turbines themselves. and they usually come in two types. The horizontal axis turbines, which is the typical turbine that you see when even looking into wind farms. That is the ones that look like a big fan, for lack of a better description, and vertical axis. Now, both of them have their own advantages and disadvantages. All right, here are some of them. So the horizontal axis requires a direction, a specific direction to be fixed in, right? And all you need adjusting apparatus to change the direction that it's facing. And it is best used at higher altitudes, right? Of course, those turbines actually produce lower drags, so you'll have lower losses in energy because of the design of the turbines. The vertical axis, however, doesn't need a specific direction to work, and it actually is can be a lot smaller and produce less noise. But because of its design, it has a higher amount of drag, so you will lose more energy in actually generating. Now, here's an example of the costs, right, associated with the project. Bearing in mind that this is assuming an ideal situation. For my example, I'm using the Endurance E3120, which is a comparatively low-end turbine, which is a capacity of 55 kilowatts in power generation, and it is listed at 250,000 euros on many different marketplaces, right? Again, assuming ideal consumption and performance rates, you need about, at bare minimum, 16 turbines, and those turbines will add up to 4 million euros, which is quite a lot for a small community. All right, moving on to selection of these sites. Now, in selecting these sites, you'll have many things to consider, right? Whether it be offshore, whether it be on land, and of course the impact on the environment in installing these farms. Offshore, of course, being more expensive due to having a stronger infrastructure requirement, but the trade-off for that would be that you'll have a higher wind speeds and more constant wind speed because there is little or no obstructions in the way. Of course, the cost will be higher the cost will also be higher due to the requirements of maintenance. To get your maintenance crew out there, depending on where exactly offshore the farm is, would be a little undertaken, as opposed to a land-based structure, which would have lower operating costs and lower construction costs. But unfortunately, your wind will be blocked due to other obstructions such as trees and buildings and other things such as that. Moving on to the environment. Manzanilla itself is a forested area, even though there is a community living there. The majority is filled with trees. And in those trees, you have multiple different types of wildlife. One in particular is the red howler monkey, right? Which is currently protected under the Conservation of Wildlife Act in Trinidad and Tobago, right? And in the in Loop TT, there was an article stating that there was someone petitioning for the application of the environmentally sensitive status for the red howler monkeys to make them even more protected. Right? Manzanilla itself, in addition to the land-based animals, you have migratory birds constantly flowing through the environment. And if you were to install, say in particular, an offshore wind farm, you would be disturbing their movements and also causing injury. In addition to that, in particular for offshore drawbacks, you would have to be concerned about pilots going to offshore installations, such as oil rigs. For there are a few oil rigs on the eastern coast of Trinidad and Tobago, and they would need to be they will need to make some changes to their flight paths due to these new turbines in the area. Now, in conclusion, we have the wind speeds necessary for power generation in the area, but just taking into consideration the turbine cost alone, which is usually between 30 to 50% of the project construction, the cost would be way too high for such a small community to try to pay back. And the environmental impact of the area would be high as well, due to disturbing the wildlife on land or offshore, depending on which direction you want to go with. Now, I thank you for your time. If there were any other questions, you can email me at m.polisher@outlook.com, or you can email Dr. Comerbatch at utt.edu.tt. Once again.
Okay, thank you very much. Okay, we have some questions here. Is there anybody? We have.
Yeah, yes, we do. I'm seeing some questions here. Well, actually, I posted a question here, Terence, and I do believe that Anil is online. The quarter.
Right. Okay, good. So the first question, Anil, is what height was the wind measurements taken, and were the wind speed measurements correlated to hub height of the wind turbine? And what about capacity factor? Anil?
Yeah, good day, everyone. All right, so based on this question here, the data, I don't have the exact values. So that question I will pass on. If you can email that to Dr. Comerbatch or Mr. Polisher. Okay,
good. We will do that. Well, another question is related to, I think it was mentioned, because the Manzanilla area is sparsely populated. Well, you mentioned in the title is feasibility. Is it economically feasible to run the wind farm?
Currently, no, because due to the small population that exists in that area, and the area that the study was done, he bordered a certain radius, and the project turned out to be not feasible at this time.
So the follow-up to that is it possible to take a wider catchment area for the farm?
Yes, it is possible, but again, we'll have to conduct another study again to see if it will be feasible for the area.
So is it limited? The farm is limited to a range of possible clients?
Yes. So he tried to incorporate some of the commercial businesses as well as the general public to try to look at the total power required to see if and how much turbines would have been required, and then look at the payback period. So the radius that he chose, it turned out to be not feasible.
Okay. I think question. Are there any? Yeah. Sanjay,
yeah,
you wanted to
take one more question, Terence, and then we move on to the next presenter.
Okay, good. We have some other questions here, so we'll email it to you. One question was the issue of power intermittency considered in the feasibility assessment?
Yes, the power intermittent, no, I'm not sure about this one.
Okay, good, and we will send the questions to you.